Hi friends, today I am going to discuss about the Iupac nomenclature of coordination compounds. Coordination compounds are the compounds which contain a central metal atom and some ligands are attached with that. So today I am using some set of rules to find the nomenclature of those kind of coordination compounds. So let's start with the first rule. The first rule is the cation is named first in both positively and negatively charged coordination entities. So I'll use an example to explain this rule. Let's take the example of K2FeCN 6 times. This is a coordination compound. Here I'll tell you the terms like K2 or potassium which is present outside the coordination sphere is called a counter ion. And here inside the coordination sphere iron is there which is a central metal atom and cyanide is a ligand in that. So finding the oxidation state of the central metal atom is the base of finding the coordination compounds naming. So let's start writing the oxidation state of iron by using the counter ion first. Here counter ion is potassium and we know that potassium is +1 and there are 2 potassium, so the overall charge of potassium is +2. And the charge of counter ion and the coordination sphere are opposite each other. Since the counter ion is +2, the charge of coordination sphere is -2. Okay. So now start putting the charges inside the coordination sphere from ligand onwards. We know that cyanide is 1-, but there are 6 cyanides, so total -6. And to find the charge of the coordination sphere in that the metal, let's put X for iron. And to calculate the total charge, X - 6. Means the charges inside the coordination sphere will be equal to the charge outside the coordination sphere. So x - 6 is equal to -2. So x is equal to -2 plus 6 equal to +4. So this is the charge of the central metal atom. One more example I'll tell you. COCl3 NH3. NH3 thrice Cl3. In this, chloride is a central metal atom. And for finding the charge of the chloride, we know that chloride is 1-, so there are 3 chlorine, so that 3- is the charge of the counter ion. To balance the charge, let's put +3 for the coordination sphere. And for each ligand, first you start putting the charges. Ammonia is a neutral ligand. It is 0. And chlorine is 1-, so total it is -3. Why? Because there are 3 chlorine atoms. And cobalt, let it be X. And you take the total charge inside the coordination sphere, which is X - 3 plus 0 equal to the one which is written outside as +3. And X is equal to +3 plus 3, which is equal to +6. So this is the charge of the central metal atom. So this is how you calculate the charge in the beginning of the question itself to calculate to find the Iupac nomenclature of coordination compounds, and from that you identify which is positive and which is negative. Positive, we know that it's cation and negative is anion. Here you see the first example, potassium is positive, means counter ion is positive, and coordination sphere is negative, or that is an anion. Similarly, the second case or second example, the one which I told you, in that coordination sphere is +3, which is cation, and the counter ion is -3, that is anion. So whatever it is, like coordination sphere, whether it is cation or anion, when you start writing the naming of a coordination compound, always you start writing from cation onwards. The cation is named first. Means in the first question, you start writing the name of potassium first. Don't write the name of the coordination sphere because it is positively charged. In the second example, you start writing the name of this much. I mean the coordination sphere first. Don't start with the counter ion. Got it? So the name can be start with either counter ion or coordination sphere. It depends upon the charge. For that, the first step is to calculate the charge of the coordination sphere, as well as you can calculate the charge of the central metal atom. Why? Because we need to use the charge. Like in coming rules, I'll explain when we need to use it. Okay. Now the second rule is no space should be given to the names in the coordination sphere. For example, again I am taking the first example, K2 Fe Cn 6 times. So when you take this much is the coordination sphere. In that coordination sphere you can see iron and cyanide. Two different ions are there. One is iron and another one is cyanide. So when you write the name, don't give space between these two words. See the second example. In that, cobalt is there, chloride is there, then ammonia is there. So these three words when you write as a name, don't give space between the words. But you can give space between the counter ion and the coordination sphere. Means in the first example, after writing iron and cyanide, when you write potassium, the order I'll tell you. So between the potassium and the coordination sphere, you give space. That space can be mandatory, but inside the coordination sphere, no need to give space. This is the second rule. Now the third rule is the ligands are named in the alphabetic order before the name of the central metal atom. It means when you start naming the coordination sphere, for example, the same example I am taking, K2FeCN 6 times. In this, when you start writing the name inside the coordination sphere. But in the first rule I told you always potassium to be named first. That is correct. But when you write the name inside the coordination sphere, always you start with the ligand first. Don't write the name of the central metal atom. Start with the ligand. But if there are one or two ligands, more than one ligands are there, then you follow alphabetic order. In this example, the second example as I told you, COCl3 NH3 thrice. NH3 thrice Cl3. In this, when you write the name of the coordination sphere, it means only I'm talking about the part which is inside the coordination sphere. Inside the coordination sphere there is cobalt, there is chloride and also ammonia. These three species are there. So, but when you start writing the name, always you start with the ligand. There are two ligands. But still, because of the different names, you have to use alphabetic order. So, ammonia, A comes first, then chlorine. So, C is later. So, always you start by using alphabetic order while writing the name of the ligand. That also comes before writing the coordination central metal atom. That is the third rule. Now, how to name the ligand? That is number 4. Naming the ligand, all the anionic ligands are ending with the letter O. Anionic ligands are ending with the letter O. So here in the table I have given the anionic ligands like Cl minus, Chlorido, Bromido for Br minus, F minus is Fluorido, Iodo for I minus, OH minus is Hydroxo, C2O42 minus, Oxalato, NO3 minus, Nitrato, NO2 minus is Nitrito and ONO minus is Nitrito O. This I'll explain. NO2 minus and ONO minus are called the ambident ligand. This you have already studied before this topic. Ambident ligands are the ligand which has two donor atom. Here nitrogen as well as oxygen are the donor atom. So when you write the central metal atom with NO2, it means nitrogen is connected with the central metal atom. Such case you need to use the name NO2N. It shows nitrogen is connected to the central metal atom. But when you write the coordination sphere inside, M with the ONO, central metal atom with the ONO is there, it means oxygen is connected with the central metal atom. Such case you need to use Nitrito O represents oxygen is connected with the central metal atom. So that you need to learn properly. Then SO42 minus, which is sulphato, Cn minus is cyano, Nc minus is isocyano. Again these two are ambident ligand. But in that ambident ligand names are different, cyano and isocyano. But in the previous case both are nitrito. So that to differentiate those two we are using the letter N or O accordingly. But here the names are itself is different, so that no need to give any other letter to differentiate. But again coming, SCN and NCS. These two are two different ligands, but they are also ambident only. In this case also, we use the letter S and N to represent SCN and NCS because both the names are similar. Thiocyanato. And finally carbonate is carbonato. So always ending with the letter O. Why? Because all these ligands are anionic ligands. So this table you have to study for your exam. Similarly, some neutral ligands are there. Neutral means the charge will be 0 for these ligands. So instead of telling water, we have to say aqua. Ammonia can be written as amine. And see the spelling AMMINE. Spelling that you need to be more careful because we have to use 2M. Carbon monoxide can be written as carbonyl. NO, nitric oxide, can be written as Nitrosyl. CH3NH2 is methylamine. En, normally En represents NH2CH2CH2NH2, which is ethane 1,2 diamine. PPh3 is triphenyl phosphine. So these are some of the common ligands which is used to come in your CBSE board exam. So you have to study this. So I'll be attaching this sheet along with my video. So you have to go through this table also. So that is a fourth rule. Anionic ligands are ending with the letter O, but the cationic or the neutral ligands have no change, like water. Ammonia can be written like aqua, amine, carbonyl, nitrosyl, etc. So I hope you understood that rule. Now the fifth one is prefix. Prefix to be used. Again I am going to the same example only. K2, Fe, Cn 6 times. Here when you identify the ligand name, as I told you now, it is Cyano. Cyano is a ligand name. But there are 6 ligands. So you need to use a letter or the prefix hexacyano. So mono we don't use normally, but di, tri, tetra, hexa, tetra, penta, hexa, etc. can be used according to the number of ligands. So while writing the name of the ligand, always you follow alphabetic order, that is must. Accordingly, the prefix also to be used to indicate the number of ligands. Now, next rule is, in some cases, the ligand itself is having some words like di, tri, etc. For example, I'll tell you, see, COEN, thrice, 3 plus. This is a coordination compound. Here En, name of that ligand in the table I can see, ethane 1,2 diamine. So di, the letter di or the word di is already there in the name of that ligand. Okay, so such cases, here 3 times. So normally I told you if it is 3, it is tris, a tri. But already the word di, tri, etc. the words are already there in the coordination sphere of these ligands. Then instead of di, tri, etc. prefixes, you need to use bis, tris, tetrakis. Means in this example, instead of using tri, you have to use tris. Tris ethane 1,2 diamine. And remember, always ethane 1,2 diamine to be written inside the bracket. And see the spelling also. Ethane 1,2 diamine, this amine is single M only. This amine is single M, but ammonia I told you this is double M. So that also to be very careful. One another example which I have written already here. NiCl2 PPh3 thrice. PPh3 twice. Here twice, 2. 2 represents normally it's di, but in this case we need to use bis. So this rule is mainly applicable for the last 2 ligands, ethane 1,2 diamine and PPh3, triphenyl phosphine. Only in these two, di and tri, these kind of words are there in the name of the ligand itself. Okay, so when you write the name of these two only, you should be little more careful about this kind of words. So I have talked about all the names of the ligands, including the prefix, alphabetic order, anionic ligands, neutral ligands, all those. Now let's go to the metal atom. Metal atom, as I told you while writing, again the same example, or let's take another example. K2 Fe CN6, same example I am taking. In this, first you start with the potassium because it's positive. Next you write the coordination sphere, but in that you start with the ligand because as I told you, the ligand to be named first, followed by central metal atom, then only central metal atom. And when you write the ligand, it's cyano, but use the word hexacyano. Why? Because it is 6 times. After that, you write the name of the central metal atom. But after writing the central metal atom name, you have to write the oxidation state inside the bracket or inside the parenthesis, so that you don't forget. After writing the central metal atom name, write the oxidation state inside the bracket. But how to write the name of the central metal atom? Again, one more rule is there. That is, if the complex or if the coordination sphere is positively charged, K2 FeCN 6 times. Here I told you this is +2 and the coordination sphere is negative. The other example, COCl3 NH3 thrice Cl3. In this example, chlorine is minus, so coordination sphere is positive. So in the first example, coordination sphere is negative. Second example, coordination sphere is positive. If the coordination sphere is negative, then while writing the name of the central metal atom, you have to use ATE at the end. This is the rule. See, if the coordination sphere of the complex is anion, the name of the metal ends with the suffix ATE. But if the coordination sphere is positive or neutral, some case you will get charge as 0, then no need to change. Don't use any suffix. Just write the same name, no change. Cobalt as cobalt only, same name only. But in the first case, iron, and again the letters or the names of the central metal atom which is derived from the Latin name, don't use the same name like iron with ATE. Instead you have to use ferrate, gold, aurate, silver, argentate. But platinum you have to write as platinate only. So the metal name or the element's name which is derived from Latin name, always you have to use Latin name then ATE. But the same iron, when it is coming in another compound in which the coordination sphere charge is positive, such cases it is iron only. So wherever ATE is to be used, then only use Latin names. Otherwise you write the normal name. So I hope you understood all these rules. So while writing the name of the coordination sphere, if you follow all these rules one by one, then the name can be written easily. So by hearting this table with the name, charges, everything is important. So I'll tell you some of the examples. I'll show you some of the examples how to write the name of these coordination compounds. Let's discuss some examples. In the first question, PTNH3 twice Cl NO2. There is no counter ion and there is no charge of the coordination sphere also. So the charge is plus 0. NO2 is -1. You can refer the table for that. NO2. I'll show you. NO2. So you see NO2 minus. NO2 minus represents -1. So for the charges you may refer the table. Chlorine. Chlorine is -1. NH3. Ammonia is a 0. Neutral ligand. So platinum, let it be X. So to calculate X plus 0 -1 equal to 0. X is equal to +2. Why? Because this -1 will go, this -1 also will go to the right side, so makes +2. The charge is +2. And there is no counter ion. So if there is no counter ion, there is no confusion. You have to start writing the name of the coordination sphere itself. But inside the coordination sphere, start writing the name of the ligand first. Identify the ligand name. NH3 is amine. Cl is Chlorido. NO2 is Nitrito. Use alphabetic order. We can start writing amine first. But there are 2 times amine. So use the letter or the prefix di. Diamine. Starting letter is capital. Diamine. Then Chlorido. In alphabetic order, C comes after A. Chlorido. See, I'm not giving any space between the words. Chlorido. I told you that as a second rule. Then Nitrito. Again no space. N small letter only. Nitrito. And the name of Nitrito is completely written like Nitrito N. Why? Because it is an ambident ligand. Then you write the central metal atom platinum. Platinum, not platinate. Platinate come comes only if the charge of the coordination sphere is negative. Here it is 0. 0 and positive, same name, platinum. Again, no space and P is small letter only, not capital letter. Platinum. After writing platinum, you write the charge. The one which we found now, it is +2. That is in Roman letter inside the bracket. So diamine, Chlorido, Nitrito, platinum 2. This is how we have to write the name. Second one. This is the first question A. Second one. K3Cr C2O4 thrice. K3. K3 is +3. Why? Because one potassium is +1. There are 3 potassium. Total +3. So the charge of the coordination sphere is -3. It should be equal and opposite. C2O4. C2O4, I will show you C2O4 here. This one. C2O4 is oxalato with a 2 minus charge. This is the charge. Superscript. So that 2 minus we multiply with 3. Why? Because there are 3 times. So 2 into 3 is -6. And chromiums, let it be X. And take the total charge inside the coordination sphere. X minus 6 is equal to -3. So X is equal to -3 plus 6 is equal to +3. So we found the charge of the central metal atom. Now start writing the name of the coordination compound by writing the cation first. Here counter ion is a cation. So we write potassium first. And again don't use tripotassium. Di, tri, etc. prefixes to be applied only inside. Inside in the form of ligand. But for counter ion, don't write the prefixes. Just write the normal name. Potassium. After writing potassium, you have to give space because we need to write the coordination sphere name. We finish the counter ion. So potassium space. Then inside the coordination sphere, start writing with the ligand. Oxalato. But there are 3 times. So trioxalato. Trioxalato. Then chromium is a normal name, but you see the charge of the coordination sphere. See, the charge is -3. I told you na, -3. The negatively charged coordination sphere, the central metal atom name is to be changed to chromate. Not chromiumate, it is chromate. And finally write the charge inside the bracket, +3. So it is Roman letter 3. So we gave space only between the word inside the coordination sphere and outside the coordination sphere. Inside the coordination sphere, no space. One more example, C. Chlorine is a counter ion, -1. Central metal atom is cobalt, let it be X. Coordination sphere is +1. Why? Because chlorine is -1, which is outside. En is a neutral ligand 0, and inside the coordination sphere this chlorine is -1, but there are 2, so total -2. So X minus 2 plus 0 equal to +1. X is equal to +3. So this is the preliminary step. Next you start writing the name of the coordination sphere first. Why? Because it is positively charged. No counter ion. And inside the coordination sphere, Chlorido and ethane 1,2-diamine. C comes first. And that too, dichlorido. Dichlorido, why? Because 2 times chlorine. Dichlorido, then ethane 1,2-diamine, I told you, bis. No space, bis. Then ethane 1,2-diamine. Ethane -1,2-diamine. This is how you have to write ethane 1,2-diamine, and always inside the bracket. That also don't forget. After that you write cobalt. And don't write cobaltate. Why? Because the coordination sphere is +1, positive. And write the charge inside the bracket in Roman letter, which we found as 3. Now you give space. Then at last you write chloride. Why? Because chloride, this chlorine is acting as a counter ion. When chlorine comes inside the coordination sphere as a ligand, then only chlorido. Now it is outside, so it is normally chloride. And if it is Cl2, don't use dichloride or trichloride, something like that. Just use chloride always, irrespective of the number of chlorine atom. Remaining Two questions you have to practice, please. And I hope you understood how to name these coordination compounds. So please follow, use these rules and find answers of more questions. Thank you all.